Hello everyone, and welcome to the Overview of Challenges lecture. So throughout this course, you're going to be receiving challenges, and these challenges are going to allow you to test your understanding of Postgres and basic and more advanced SQL commands as you go throughout the course. The basis of these challenge scenarios will be that you've just been hired as a SQL consultant for a DVD rental store. So that's going to be the basic background as we give you challenges throughout the course. So as far as solutions to the challenges are going to start off very simple and basically be asking you to repeat what you just saw in the previous lecture. So don't worry if you're finding challenges to be very basic at the beginning, because that's how they are. Later on, you're going to be provided with solutions or walkthrough video solutions for the tougher challenges. So at first, the challenges are going to start off simple and ask you just to repeat what you just saw in the previous lecture, and there's not going to be a specific solution to that challenge, because you can just reference the previous lecture. Later on, though, as the challenges get harder, you'll either be provided with the solutions at the next lecture after the challenge lecture, or we'll have a whole walkthrough video in case it's a very difficult challenge. Keep in mind that challenges may show up unannounced, so always be ready for them. With all that being said, I hope you enjoy these challenges, and I really hope you do them. They're going to be a great way for you to get a chance to test your understanding and test out your SQL knowledge on the example database as we go along through the course. Okay, with that all being said, I will see you at the next lecture. Thanks everyone. Hello everyone, and welcome to the SQL Statement Fundamentals section of the course. This section is going to focus on SQL syntax. And what's really important about what you're going to learn here is that the syntax in this section can be applied to any major type of SQL database. So if you move on to work on like a MySQL database or an Oracle database, the SQL syntax you learn throughout this section of the course, and anytime we're going to be learning specific SQL syntax statements and queries, you're going to be able to apply that knowledge to basically any major type of SQL database. So we're going to start with the basics and have challenges along the way to test your understanding. With all that being said, let's go ahead and get started. Welcome everyone to this lecture on the select statement. Select is the most common statement used in SQL, and it fundamentally allows us to retrieve information from a table that exists within a database. Later on, we're going to be learning about how to combine the select statement with other statements to perform more complex queries. So what's the actual example syntax for a select statement? Well, after opening up the query editor, what we're going to write for our most basic select statement is select column name from table name. And you'll notice that in general, we capitalize the SQL keywords. This actually isn't 100% necessary. SQL will still run even if you don't capitalize these, but it makes it much easier to read what are the fundamental SQL syntax statements versus what are the column names or table names that you're yourself editing, depending on what you actually want. So the most basic syntax here is we choose a column name from a table. So let's see how this actually works within PostgreSQL. So we already know that we have a database, and then we right-click on that database and we open up that query editor. In our case, it will be the example DVD rental database. And so the way PostgreSQL operates is inside of this database, you're going to have some number of tables. Here we have an example of 3 tables. And recall then each of these tables is essentially like a spreadsheet. We have columns and then rows of data. And here I've just made up some data. So each of these tables has columns 1, 2, and 3, so C1, C2, C3, and then rows with made up information. When we actually say select column name from table name, PostgreSQL essentially reads this a little bit backwards. It first has to decide what table you're referencing. It already knows what database you're referencing because that's how you open the query editor on that database. So it takes a look at what table name you're looking at, and then it's going to take a look at the corresponding column name. So, for example, we could say select C1 from table 1, and it would look something like this. It's actually grabbing column 1, and it will return back that entire column, and X, Y, and Z. If we want to select multiple columns from a table, we can say column 1, comma, column 2, etc. You just separate out the column names by a comma. And keep in mind, these don't need to be in order. So if you only wanted column 1 and column 3, you would just say select the names of your columns separated by commas and then from the table you want them in. If you actually want all the columns from a table, you can use an asterisk symbol in order to request all the columns from a table, essentially just asking for the entire table back. So you'll say select, an asterisk, and then from table. In general, it's not good practice to use an asterisk unless you actually want every single thing in that table. And what's going to happen here is if you use that asterisk in the select statement, it's going to automatically query everything, which increases traffic between the database server and the application, which can slow down the retrieval of results. So you should really only be using that syntax if you actually want the entire table back with all the columns in it. If you only need certain columns, do your best to only query for those columns. Let's go ahead and walk through some examples in our DVD rental database to get some practice with these basic select statements. I'm going to open up pgadmin. Alright, so I've opened up pgadmin. I'm going to click down on servers. Note that I have different versions of PostgreSQL installed on this computer. Go ahead and choose the one that you installed for your computer. I'll go ahead and choose PostgreSQL 12 since that's what we restored DVD rental on. I've now connected to that server under PostgreSQL 12, and now I want to query the particular database inside that server. So that's going to be DVD rental. I right click, and then I'm going to open up the query tool. I take a look at the query tool and I have the query editor as well as the data output. So let's practice our very first query to this database. So if you're ever curious of what tables are actually available to you in your database, what you can do is underneath DVD rental, you can open up schemas. You'll see there's a public schema, keep going down, and you'll see there's tables here, and you can expand on tables, and it'll show you the various tables available to you inside of this database. And you can check out the resources for this lecture or the previous lectures. We actually have a mapping of those tables and the relationships between them. We'll talk a lot more about joining tables together and also programmatically asking a database what tables are within it. But right now, we'll just do this through the pgadmin graphical interface. So I can see there's 15 tables here. And if we click on one of these tables, we can later on see what columns are available, etc. So let's go ahead and start by asking for an entire table back, or all the columns in a table. I say select, and then I type in an asterisk there, from, and then we'll say actor, semicolon. And then I'll go ahead and run this. And if you're on Windows, you can choose F5 to quickly run that. And you'll notice that it has the data output. I'm going to kind of move this over so we can see this. And we can see here it has the actor ID, the first name, the last name, and then the last update. And we can scroll down here and see the various results. So again, this returns back all the columns. If I only want a single column, let's say I only wanted the first name, then I just look at the column name, which is first underscore name, say first underscore name, and then I'll go ahead and run that. And now I only get back the first name. If I want the first and last name, I would take a look at those column names, which I can always refer to over here on the side. Last name's available there, and then run that. Okay, so I can see first name and last name, and keep in mind, they actually don't need to be in any sort of order. If I wanted the last name to show up first, I could say last name, comma, first name, run that, and it would show me in the order I requested. The last name column showing up first, and then the first name. Everything's linked here by what row. So we can see Penelope Guinness, Nick Wahlberg, etc. Now a few more points I want to show you is that you notice that I capitalized the SQL syntax keywords, but even if these were all lowercase, select, and then I put from in all lowercase, and I run this, it will actually still work. It's the same thing. However, it's much easier to read, and it's just standardized notation if we just do this in all caps, and then I can quickly realize if I'm coming back to this that select and from are the keywords. And notice pgadmin also highlights them for us. You'll also notice that I have a semicolon here. The semicolon is to denote the end of a query, but if you delete that semicolon and still run this, you'll notice it works just fine. So things like capitalizing those SQL keywords, as well as adding in that semicolon, really helps as far as readability is concerned, especially if you're going to be sharing these SQL queries with someone else. It can read very clearly where this actual query is meant to end, as well as what commands you're actually using. You can use the scratch pad here if you want to kind of play around with things later on as our SQL queries get more complex. You may want to work a little bit on the scratch pad And I'm going to zoom out just so we can see this clearly. There is a query history that you can click here, and you can see the various query histories. And then you can always copy them, or you can copy them directly to the query editor. So for example, if we come back here, maybe to select first name from actor, I can say copy to query editor, and it jumps back to the query editor, and I can see select first name from actor is already there for me. All right. And then if I wanted to, I could run this and edit it in any way I want. So I can just double click here and start editing for another table. Maybe I want all the columns from another table. Let's say select everything from city, semicolon, hit F5, which is essentially a refresh or running this. And we can see here city ID, city, country ID, last update. Okay, so those are the very basics of the select statement. Coming up next, we're going to have just a few challenges to make sure you understood all this. I'll see you at the next lecture. Welcome back, everyone, to your first challenge task regarding the select statement. In general, after most major concepts, we'll have a quick challenge just to test how well you're understanding the concepts, and these challenge structures will go as follows. We'll first start off with a business situation. So a big part of being good with SQL is being able to translate a business question or business situation into an actual query that gives you insight or information or just directly answers the business question you have. So we'll start off with a business situation, and then we'll move on to the challenge question, which focuses a little more on the actual SQL statement. Then we'll give you the expected answer, or what the expected answer structure should look like. Then we'll give you hints, and then we'll finally show you the solution. And between each of these steps, I'll give you fair warning that the next hint or solution is coming up. So let's get started. So the actual business situation we have here is that we want to send out a promotional email to our existing customers, which means we're going to need some information. So let's go ahead and translate this business situation to a general SQL query. What we need to know is the names of these people, their first and last names, so we can address them in this email, and then their actual emails. So how can we do this? Well, we're going to be using a select statement to grab the first and last names of every customer, as well as their corresponding email address. Now, if you want, you can directly jump straight into pgadmin and see if you can figure out what the correct SQL query looks like and what the correct table to query is in order to actually answer this question. Coming up next, I'm going to show you what the expected answer should look like. Okay, here comes the expected answer. So, the expected answer to be displayed after successfully running your query should look something like this. I should see a first name, a last name, and then a corresponding email. Something to keep in mind here is that it may not actually be displayed in this exact order. Later on, we'll talk about how to order results, but right now, the way PostgreSQL works, it just tries to return the results in the most efficient way possible, which depending on your version of PostgreSQL and your actual machine, may sometimes slightly change the order of things. But in general, in the data output, I'm expecting a first name, a last name, and then an email. Okay, so coming up next are some hints. So here come the hints. So the hints is that you'll want to use the customer table if you haven't figured that out already, and you're going to need to figure out what columns you want in the customer table. So there's different ways you can do that. One is you can use the table dropdown to view what columns are available in pgadmin. Recall there's that left-hand side where you can just drop down and expand the table in order to see what columns are available. Or what you could also do is just say select asterisk from customer, and that would return back the entire table, and there you can view all the columns inside the customer table. Okay, so those are the hints. Hopefully, after seeing these hints, you can successfully run that query and figure it out. Coming up next is the actual solution. So for the solution, let's go ahead and program it out in pgadmin and work through it. Okay, here I am at pgadmin at my query editor. First thing I need to do is figure out what the actual table I should be looking at. So I've already connected to DVD rental up here. I could expand on the schemas, expand on public, and see the tables. And hopefully you're able to figure out that the most likely table would be the customer table. And if we expand on the customer table, I could expand on the columns and see there's a customer ID, a store ID, first name, last name, email, address, etc. So really what I want is the first name, the last name, and the email from the customer table. So the way I can do this is I can say select, and I can zoom in here a little bit, and then we'll say first underscore name, last, comma, last underscore name, comma, and then their email from, in all lowercase, that customer table. I'll put a semicolon to denote that's the end of my query. I'll go ahead and run this, and now I take a look at the data output, and I can see the first name, the last name, and the email. All right, so that's it for the select challenge. Hopefully this was pretty straightforward. If you have any questions, feel free to post to the Q&A forums. I'll see you in the next lecture where we start discussing select distinct. Welcome back, everyone, to this lecture on select distinct. Sometimes a table contains a column that has duplicate values, and you may find yourself in a situation where you only want to list the unique or distinct values in that column. The distinct keyword can be used to return only the distinct values in a column. The distinct keyword operates on a column, so that means the syntax looks like this. We say select, and then distinct right in front of whatever column we're interested in grabbing the unique or distinct values from, and then we'll specify what table this column is in. Sometimes, to clarify which column distinct is being applied to, you could also add in parentheses for clarity. So note that distinct on a column works with or without parentheses. This is what it would look like with parentheses. And again, it will work without parentheses as well. Later on, when we learn about adding more calls, such as a count call and a distinct call together, some sort of parentheses structure will actually be necessary to clarify what is actually being called on what. But we're going to see that in a future lecture. Let's first think about what does it actually mean to call distinct on a column. Imagine a table of people who were surveyed to choose a color. So here we have the names of the person, just their first name, and then the color choice they made. Let's imagine we actually called select distinct from the name column from the color table. We'll notice that we have two instances of David inside this name column, which means when we actually select the distinct names from this table, it's going to return back the following, just the unique first names in this actual column. Keep in mind that given the previous example, we don't really know if the person with the name David was a duplicate entry who happened to change their color choice later on as the same person, or if it was two different people that happened to have the same first name. Calling distinct on this particular column just answers the question, what are the unique first names that are there in that table or in that column? It probably makes more sense to ask how many types of unique color choices were there. So what we can do is say select distinct choice from the color table, and here we have all the distinct or unique color options that were chosen. Let's go ahead and see a couple more cases of when distinct would be useful. We're going to jump over to pgadmin. All right, here I am at the query editor. What I'm going to do is first explore the film table, and there's different ways I can do this. Since this is a pretty small database, I could either expand on this film table to see what columns are available, film ID, I could scroll over here, title, description, or I could just say the following, select everything from film. And it's okay to do this since this is basically kind of a toy database and toy table. It's not going to be huge. So we'll go ahead and just run that. And we can see here we have the film ID, the title, description, release year, language ID, and I can keep scrolling to see other information and other columns that are available inside of this film table. So let's think about what kind of questions distinct can help answer. Distinct really helps when we want to know the unique values inside of a column. And if we take a look at these actual tables here, something we may want to know are how many different release years do we have inside of this film database. And what we can do here is say select distinct, and I'll put it in all caps since we're treating it as a SQL keyword. You can see it's highlighted as such. And then we'll call it on release underscore year from film. So if I run this, what's happening here is it's going to return back just 2006. So this quickly answers the question, how many unique release years do we have inside this film table? And it ends up we just have one. All of these films were released in 2006. If we take a look back at this, I should also note that we can add in parentheses. And we can see here that it's directly connected to distinct. And if we run this, we'll get back the exact same result. And for some people, this is more legible coming back to their old SQL queries. It works either way, so it's really up to you if you want to use parentheses or not. Let's come back and take a look at the entire table again, just so we can check out the columns. You'll notice here we have the release year. Something else that's interesting are the rental rates. And it does look like we have different numeric rental rates. So some movies rent for $4.99, some rent for 99 cents, others rent for $2.99. Distinct can help us answer the question, how many unique rental rates do we have? What we can do then is just say select distinct, and with or without parentheses, we can say on rental rate. We'll go ahead and run this. And here we can see that we have three distinct rental rates, essentially a low tier at 99 cents, $2.99, and $4.99. Later on, we'll be learning how to actually sort these or order them based off a certain value. But right now, PostgreSQL just returns back information as efficiently as possible. So you may actually get these in a different order depending on your operating system. All right, that's it for the lecture on Select Distinct. Coming up next, we're going to quickly test your new skills by giving you a quick little challenge on Select Distinct. I'll see you there. Welcome back everyone to this quick challenge to test your skills on Select Distinct calls. We'll go over an example situation, correspond that to a SQL challenge, then show you the expected results, and if you need them, we'll show you hints and the solution. So the situation is we have a visitor who isn't from the USA, they're from Australia, and so they're not familiar with the Motion Picture Association of America's movie rating system, such as PG, PG-13, R, etc. So you need to know what are the types of ratings we have in our database. So what ratings do we have available? See if you can actually change that question and correspond it to the correct SQL challenge. Okay. So the SQL challenge is use what you learned about Select Distinct to retrieve the distinct rating types our films could have in our database. Coming up next is the expected solution or expected result. So the expected result should look something like this. It may not be in this exact order, but you should get the ratings G, PG, PG-13, R, and NC-17. Okay, here are some hints if you need them. So the hints are to use the film table, and you can use select asterisks from film to see what columns are available, or use the drop-down table menu in pgadmin to see what the appropriate column is to actually query from the film table. Coming up next is the solution. So the solution is actually very simple. It's just select distinct rating from film. Okay, and you can go ahead and run that in pgadmin if you want to just run the solution for yourself. Okay. Coming up next, we're going to start talking about one of the most useful SQL fundamentals, which is the select where statement. I'll see you there. Welcome everyone to this lecture on the count function. The count function returns the number of input rows that match a specific condition of a query. We can apply count on a specific column or just pass count and then an asterisk. We will soon see this should return the same result because count is merely reporting back the number of rows returned, which is going to be the same regardless of what actual column you're looking at. Let's see a simple example. Here again we have that table with a couple of names and then their color choice. Let's imagine we called select count name from table. Notice here count does need the parentheses because it's a function acting on something. So it won't work without the parentheses. Keep that in mind. If we were to count the number of names from table, that's just asking for how many rows are there in the name column, which is going to be 4. So the result will be count 4. So again, it's simply returning the number of rows in the table. In fact, this should really be the same regardless of the column we call, because each column has the same number of rows since they're literally in the same table. Which is why, whether you call select count name from table, select count choice from table, or select count asterisk, which is just saying select the count of all the rows for all the columns in the table, they should all return the same thing. Since the original table has 4 rows, that means each column has 4 rows, which is why you usually just see an asterisk from the table. Now keep in mind, it's sometimes useful to use a column name instead of just providing an asterisk, because if you come back on your SQL query sometime later, it may actually help kind of stir the memory of what actual question you were trying to answer. So again, because of this, count by itself simply returns back a count of the number of rows in a table. And count is usually much more useful when combined with other commands, such as the distinct command that we already learned about. Imagine we wanted to know how many unique names are there in the table. So, to answer this question, we need to first decide the distinct number of names. Then we'll provide count on that result of distinct name from table. So the logic that's going to happen is distinct is going to figure out what the distinct names are. Here it sees that David is duplicated, so it's just going to kind of remove that, and now we have the 3 unique names, and then count is going to count the remaining rows here, which in this case is going to be 3 rows. So the end result for select count distinct name from table is 3, answering the question that there are 3 unique names in the table. It won't tell you what those names are, that would just be a distinct call by itself. And again, notice the parentheses structure here. It's informing us that we are calling count on the result of distinct name. If you want, you can also provide parentheses for name on distinct, although that's not necessary as we previously discussed. However, some people find this result more readable. Let's go ahead and explore some examples in pgadmin. Okay, here I am at the query editor in pgadmin. Let's select everything from the payment table, just so we can take a look at it. So we'll say select everything from payment, and I can see there's a payment ID, customer ID, staff ID, etc. There's also an amount and a payment date. Let's imagine I just wanted to know the number of rows that are in this table. Now, luckily for us, this table is pretty small, which means I could, if I wanted to, scroll all the way down and then check the actual, here on the left-hand column, it's just a count. So I could scroll all the way down and eventually I would see the correct answer. However, this is actually quite a large table. There's more than 1,000 entries. In a realistic database, you're going to have very, very large tables. So you're not going to be able to just scroll down just to see how many rows there are in this table. So one easy way to do this is just say select count, and then to make it easier to read, I'll pass in the parentheses, and it just is asking count the number of rows in all the columns. So those should all be the same, which means it's going to be 14,596 rows. So much easier to do that than scroll down until you see 14,596. And you could do this for essentially any column. So if I pass in the, let's say, amount column, again, this is just asking how many rows are there in the amount column. Well, it should be the same as the number of rows in the actual table. So notice we get back the exact same result. So when people are beginning to learn about SQL, they sometimes get confused over what column we're going to pass into count, and in the end, it really doesn't matter. It's really probably most common to see an asterisk, since, again, it doesn't matter. But sometimes it might be easier to use a column name in order to set your mindset as far as what you were thinking when you were writing this query. So if you come back later in time and you would see this query, you can see that you were probably thinking about the amount column because somebody asked you a specific question of it. So keep that in mind. It might be easier for you to actually clarify with a column name. Okay, now let's go ahead and say, just select the amount column from payment, run this, and I can see there's different amounts that people are paying, $7.99, $1.99, $2.99, $5.99, etc. Let's imagine I wanted to figure out the actual number of payment types. What are the actual number of unique amounts or distinct amounts being paid? If I were to just use distinct on the amount column, I would run this and it shows me the distinct values, $1.99, $10.99, $2.99, etc. Essentially removing any duplicates. So this answers the question, what are the unique payment amounts? However, my question is, how many unique amounts are there? Which means I should be counting the result of this. So one way I could do that is scroll all the way down and realize there's 19 rows here, or to do this programmatically, I would just say count distinct amount. I run this, and notice here, when I'm using these two functions, I will need to specify with parentheses. So I'll say count distinct amount, and then it actually ends up working. So the reason in this case that I need to use parentheses is because if I don't, PostgreSQL is going to think that I'm trying to call count on some distinct column, which doesn't exist. So this is why I need to call parentheses and specify that distinct amount should happen first before I call count on whatever this result is. And if you want, you can add in another set of parentheses just to make it more readable for you. It really depends on your personal style. And we'll get back the same result. Okay, so that's it for learning about count. Coming up next, we're going to learn about the select where statement, which is really going to help us out in a lot of different query types. I'll see you there. Welcome back, everyone, to this lecture on the select where statement. In part 1, we're just going to be learning the basic syntax structure, and then in part 2, we'll actually jump over to pgadmin and code out some examples. So the select and where statements are really the most fundamental SQL statements, and you're going to find yourself using them in almost every SQL query you do. So the where statement allows us to specify conditions on columns for the rows to be returned. The basic syntax would look something like this. We decide on what columns we want back, so we'll say select column 1, column 2, etc. And then we decide what table we want those columns from, and then after that, we can describe conditions. So we'll say where, and then some manner of conditions. So let's actually go into detail of what those conditions are like. The where clause appears immediately after that from clause of the select statement. And then the conditions are used to filter the rows returned from the select statement. And PostgreSQL provides a variety of standard operators to construct those conditions. And I want to make it clear that the conditions we show here are available in any major SQL engine, so it's not just unique to PostgreSQL. So we first have the comparison operators, and the comparison operators allow us to compare a column value to something, essentially allowing us to answer questions or queries such as, where is the price greater than $3? Or where is the pet's name equal to Sam? So those kind of statements of greater than or equal to or less than, those are the comparison operators. And you're probably familiar with the base syntax operators, at least the operator syntax signs, because they're just basic math. So for example, if we want to check for equality, we just use the equal sign. Then we also have the greater than and less than sign, the greater than and equal to signs, and then even the not equal to. And there's two ways of doing not equal to in PostgreSQL. You can have a less than and greater than sign right next to each other, or the more common way is to do an exclamation mark and then an equal sign. In addition to those, we have the logical operators, and that allows us to combine multiple comparison operators or effect comparison operators. So you're also probably familiar with these ideas of and, or, and not, and they essentially allow you to use multiple comparison operators. So you can do something like condition 1 has to be true and condition 2 has to be true, or condition 1 is true or condition 2 is true. And then you have the not operator, which essentially means the opposite of whatever condition you're specifying. So where this condition is not true. So let's actually walk through the very basic syntax of what this would look like. And we'll do this with the example table we saw before, where we have some names and some color choices. So in order to get back both columns from the table, we could just say something like select the name, comma, choice columns from table. So now let's try to get only the people named David. So there's a condition there where I want the name column to be equal to the string David. So the way I do this is I say select the name column and the choice column from table where name is equal to David. And note here in PostgreSQL we use single quotes in order to denote these strings. And also when we're checking for equality here, the capitalization does matter. Also keep in mind that I selected both the name and the choice column here. I could, if I wanted to, just select the name column from table where name is equal to David, and then I would just get back the entries on the name column. So that's not terribly useful. So keep in mind you're probably going to ask for more than just a column where you're filtering these conditions on, just as asking for name and choice. Let's imagine I wanted to do multiple conditions. So previously I have two Davids here where we have green and red. I can use those logical operators such as the AND keyword to test for multiple conditions. So here I'm grabbing the name and choice column from this table where the name is equal to David and the choice is equal to red, returning back this single row where both those conditions have to be true. Okay, let's go ahead and see you in the next lecture in part 2 where we jump to pgadmin and work through a bunch of examples available to us inside the DVD rental database. I'll see you there. Welcome back, everyone, to the Select Where Part 2 lecture, where we're going to head straight to pgadmin and code along with a couple of examples just to give you an idea of the different use cases for select, where, as well as comparison operators and logical operators. Alright, let's begin by exploring the customer table. I'm going to just select everything from the customer table so we can explore it quickly. We'll say select, and then asterisk from customer, semicolon, go ahead and run this. And I can see there's a customer ID column, a store ID, first name, last name, email, an address ID, some active Boolean, whether or not that customer is active or not, so true or false, the date they were created, last update, and then also an integer corresponding to the active Boolean, so ones and zeros for the trues and falses here. Okay, so what can we do here to start filtering out customer information? Well, maybe something I want to know is who has the first name Jared? Maybe someone comes to the store and asks me, I'm looking for some customer named Jared. So I can say select all the columns from customer. We'll go ahead and delete that semicolon. And then we'll say where, and this is where we have a condition. So we have to say the column name. In our case, it's first name. So we'll scroll over here. You can see we have first underscore name. So we'll say where first underscore name is equal to, and then single quote, capital J, and then Jared. Note how the single quotes are essentially automatically ended for you in PostgreSQL and pgadmin. Semicolon, optional if you want to end this or not. We'll go ahead and run this, and now I can see I have that information for Jared. Now let's go ahead and explore the film table to see how we can combine conditions with logical operators. So we'll say select everything from film, run that, and it looks like I have different film IDs that are unique to each film, a title for each film, a description, a release year, a language ID, rental duration, rental rate, length, etc. So let's start playing around with this. Let's go ahead and find maybe all the rental rates that are higher than $4. Recall that when we use distinct, there's really only 3 rental rates, 99 cents, $2.99, and $4.99. So I can say select everything from film where the rental rate is greater than, let's just say 4. Semicolon, go ahead and run that, and now I can see all the results that are back here are now $4.99, $4.99, etc. So they're all greater than $4. And let's go ahead and add another condition on this. So we can do this for a logical operator. Let's go ahead and choose ones that are expensive to replace. Notice we also have a replacement cost. Let's go ahead and choose the ones that have a replacement cost greater than or equal to $19.99. So we'll say and notice I don't need to rewrite where again. So the where just applies to all these conditions that I can keep linking together with logical operator. So well, rental rate is greater than 4, and let's say replacement cost is greater than or equal to $19.99. And because these are numeric types, I can directly compare them to these numbers. Note how PostgreSQL lets you know what data type it is. So there's different colors depending if I'm working with strings, whether these are keywords in PostgreSQL, or whether they're numerics. We'll go ahead and run this. And now I can see here that we have $4.99 and then the more expensive movies to replace, $19.99, $28.99, etc. And I can keep tacking on more and more, so maybe I want only certain ratings. Maybe I only want the R movies. So we can always remove that semicolon and continue on another line where we say and then maybe rating is equal to, and then single quotes R. Go ahead and run that, and now we keep filtering more and more on this, etc. And recall that here we're just asking for all the columns, but I can always just ask for only certain columns. So I can say select the title from film, and then we run this, and essentially I get a list of all the titles where these 3 conditions happen to be true, where the rental rate's more than 4, the replacement cost is greater than or equal to $19.99, and the rating is equal to R. Let's imagine I wanted to answer the question of how many titles there are where these conditions all happen to be true. Well, what I can do is simply add in a count. So I can either count title, which is essentially counting how many rows are returned here. So if I run this, it gives me back that there's 34 movies where all these conditions happen to be true. But if you remember from the count lecture, I can really pass in any column to this, or in fact, I can just write an asterisk here, which essentially just count the number of rows that are returned from the film table that satisfy these conditions. And if I run this, I'll always get back the same number. So recall from that count lecture, it doesn't really matter what actual column I apply here, because I'm really just asking the question here, how many rows are returned that satisfy these particular conditions? Let's go ahead and explore a quick example of the OR logical operator. Maybe I only want movies that have an R rating or a PG-13 rating. Well, what I can do for that is I can say where rating is equal to R, or, make sure we spell this right, rating is equal to PG-13. Notice here I'm still counting the number of movies returned here. I run this and there's 418 movies that satisfy either the R condition or PG-13. Now remember, we also have the not equal to operator in case I want everything that isn't an R movie, for example. I could say something like the following. I could say where the rating is not equal to R. And let's just go ahead and grab all the columns here so we can see the results. We'll go ahead and run this, and if I scroll over to the right, you'll notice on the rating that everything here is everything that's not R. So that's G, PG, PG-13, NC-17, etc. So we have all the ratings here, but none of these are actually going to then be R. All right, so that's it for these code-along examples. Coming up next, we're going to check your understanding by giving you a couple of challenges with these select where statements. Hopefully you can already tell this is a very powerful tool and something you'll be using quite often when it comes to your SQL queries. I'll see you in the next lecture. Welcome back, everyone, to your challenge tasks for the select where statement. We just learned how to combine the select clause, which allows us to grab columns, along with the where statement, which allows us to actually specify conditions based off those columns, using logical operators and comparison operators. So we have just 3 quick tasks to make sure you understood everything. Something I want to point out, though, is that we now know enough to answer more realistic business questions and tasks instead of just directly asking for specific SQL tasks. So from now on with the challenges, we're going to try our best to focus more on directly asking the business-related questions to more realistically model a typical task you would see as a SQL developer in a real-world workplace. So what I mean by that is, from now on, our challenge examples will focus more on something like how many customers have the first name Jared, instead of asking a question such as use select where to find Jared in the first name column in the customer table. So we're going to focus much more on trying to have you build the skills of translating a business question or business related task to an actual SQL query, since that's really where a lot of the work takes place. Okay. One last thing to keep in mind is that as you continue to learn more about SQL, especially now that we're kind of past this hump of the select where statement, you're going to soon realize there are usually many different ways to arrive at the same solution. So you should be verifying your work mainly against the expected result instead of our example SQL solution, since your SQL solution may begin to vary just a little bit from ours, but as long as you're getting the same expected result, then you're totally okay. So let's get started. So we'll go over the business situation in question, show you the expected result, so show you some hints if you need them, and then show you our solution. So the first challenge, a customer forgot their wallet at our store, and we need to track down their email to inform them. So the question is, what is the email for the customer with the name Nancy Thomas? So we open up the wallet, we see that their name is Nancy Thomas, and we want to figure out what is the email so we can inform them. Okay, coming up next is the expected result. So the expected answer should look something like this. You should eventually realize it's nancy.thomas@sequilacustomer.org. Okay, here come some hints if you need them. So the hints are to use the customer table. You should also make sure the capitalization and spelling of the names is correct. You may need to use and to combine conditions for the first and last name, and make sure to use single quotes around the string. Here comes the solution. So our solution for challenge number 1 was to select the email column from the customer table where first name is equal to Nancy and last name is equal to Thomas. If you take a closer look at that customer table, you'll realize that there's actually only one person with the first name Nancy, and That means you could just technically go off the first name, but realistically, you want to make sure to go off the first name and last name. And luckily for us, there's only one person named Nancy Thomas in our database. Stuff would definitely get more challenging if we had multiple Nancy Thomases, which means we'd probably have to send multiple emails. Okay, here comes challenge number 2. So, a customer wants to know what the movie Outlaw Hanky is about. Could you give them the description for the movie Outlaw Hanky? Okay, here comes the expected result. So the expected answer is this description, which is kind of wacky, but Outlaw Hanky is a thoughtful story of an astronaut and a composer who must conquer a dog in the Sahara Desert. All right, so here comes some hints in case you need them. Hints for challenge number 2 is to use the film table. Make sure the capitalization and spelling and spacing of the movie name is correct in case you're getting an error on that, and make sure to use single quotes around the string. Here comes our example solution. So here we'll just select the description column from film table where title is equal to Outlaw Hanky. And you have to make sure that capitalization is correct since it will actually check for capitalization matching up. Okay, here comes your next and last challenge for this little lecture. So challenge number 3 is a customer is late on their movie return, and we've mailed them a letter to their address at 259 Ipo Drive, and we should also call them on the phone to let them know. So what we want to do is, can you get us the phone number for the customer who lives at this address of 259 Ipo Drive? All right, here comes the expected result. So the expected answer for challenge number 3 should be this phone number here. Here come some hints in case you need them. So you should be using the address table. Make sure the capitalization and spelling of the address is correct, and use single quotes around the string. And finally, here's the solution. The solution is simply select phone from address, where address is equal to 259 Ipo Drive. Something to keep in mind here is that the table can share a name with the column. So notice here that the column is address as well as the table name is address. So don't get too confused here thinking it's referring to the same thing. The from is asking for the address table, the where is addressing the address column. All right, that's it for your select where challenges, and I will see you at the next lecture. Welcome back everyone to this lecture on order by. You may have noticed that PostgreSQL sometimes returns the same request query results in a different order, meaning you may have run the exact same query on your computer and saw the results in a slightly different order than what I have on my computer. So, in order to alleviate this issue if we want the results in a certain order, we can use the order by to sort rows based on a column value in either ascending or descending order. So that would be alphabetical for string-based columns or numerical order for numeric columns. The basic syntax for an order by statement would be as follows. We select whatever columns we want from the table, and then we decide to order by a specific column. And then optionally, you can add in ASC or DESC, whether you want that ordering or sorting to be ascending or descending. Notice the order by towards the end of the query, since we want to do any selection and filtering first before finally sorting. So that means order by is going to be towards the bottom of a query and one of the very last things that SQL actually performs. So we're going to do all our selection, all our filtering. If we use a where statement, that should come before the order by, and then right at the end, we'll go ahead and do any sorting. And you use ASC to sort in ascending order, DESC to sort in descending order. If you leave it blank, order by just uses ascending by default. Now what's also interesting is you can use order by on multiple columns. So this makes sense when one column has duplicate entries. Let's take a look at this example database or example table really. We have 3 columns here, company, name, and the sales for that individual at that company. Notice here that we have duplicate entries under company. So if we were to actually order by 2 columns here, we could select the company column, the name column, and the sales column in that order from this table, and then we order by company and then order by sales. What does that actually mean? Well, it means we sort everything first based off the company column. So notice we have Apple coming in first in alphabetical order, then Google, and then Xerox. And then the corresponding names also get lined up. However, we can then also order by the sales. So after you've done the sorting based off the company column, which makes sense because there's duplicate values there, within that particular company, we do a second ordering, which is by the sales column. So note the sales now is in an ascending order for each individual within the same company. So we see Andrew with 100, and then Zach with 300. And then for Google, we see Claire with 200, and then David with 500. So if you have duplicate values in a particular column, and you want to sort not just by that particular column, but another column as well, it makes sense to do an order by with multiple columns. And it's going to sort based off the order you provide. So it'll order by company first, and then by sales. Let's go ahead and explore some more examples in pgadmin on the DVD rental database. Okay, here I am inside of pgadmin. What I'm going to do is explore the customer table. So we will say select, and let's select just everything from the customer table so we can take a quick look at what the results look like here. So notice we have this customer ID, and more or less it seems to be in order except for this first one, which is 524, and then we also have the first name and last name. Let's see if we can order everything based off the first name of the user. So that would be an alphabetical order based off first name. So what we do here is, towards the bottom, we'll say order by, and then we decide on the column. So we'll say order by first name. If I don't leave anything here and just run this, it'll automatically order it here in ascending order. So starting at A all the way down. So then if you start going more and more down, you'll eventually see B's and then C's. This is the same as if I had clarified ascending order. So you may be wondering why bother clarifying ascending order there. Well, it's nice because if you come back to read this or someone else is reading your code, you can realize that they specifically wanted it in ascending order. We can do the same for descending order by adding in DESC towards the end of this order by statement. And now notice we're starting at Zachary, then Yvonne, Yolanda, and going down. So starting at Z and then going down all the way to A. Now notice here that we have different store IDs, and we also have duplicate store IDs. So we have store ID 1, store ID 2, and store ID shows up multiple times. So we have multiple entries for store ID, which basically means that this particular customer, let's say Zachary Height, goes to store ID number 1. And this second customer, Yvonne Watkins, goes to store ID number 2. So there's Yolanda, Wilma, etc. What we could do is first order by the store ID to get all the results per store, and then organize it by first name. So the way this would work is I would say first order by store ID, and if I just run this by itself, notice now I get store ID 1 first, and then if I were to continue scrolling here, this may be a couple thousand, so it might be hard to actually see this, but then I eventually get store ID number 2. And then within this, you'll notice that if we scroll back up here, I'm actually just going to select store ID, first name, and last name columns. So let's reduce this a little bit. We'll say select the store ID column, select the first name column, and select the last name column. Run this. So if we take a look at this, the store ID is now sorted starting at 1, and then eventually you scroll down, you'll see store number 2, but the actual entries themselves are in no particular order within store ID. So what I could do is say first order by store ID, which makes sense because there's duplicate values in that particular column, and then go ahead and order by first name. So after you order by the store ID, go ahead and order by first name, run that, and here we can now see store ID number 1, then everything starting in alphabetical order based off the first name, and then we scroll down here to eventually hit store ID number 2, and we can see within store ID number 2, all the first names are now in alphabetical order, starting with A. And if you want, you can always add in ascending and descending to each particular order by statement. So I could say order the store ID on descending while ordering based off first name on ascending. And notice here, it's semicolon is optional. So we run this, and now at the very top, we're starting at store ID number 2, and then seeing the alphabetical order, Aaron, etc. And then eventually, if I scroll down far enough, I would see store ID number 1. The other thing to note here is that if I select just first name and last name and run this, it will still work, which means I can technically sort by columns that I do not actually request in my select statement. Now, whether or not you actually want to do that in a real-world setting is really up to you. Typically, it would make sense to actually select the column you're ordering by because that just logically looks better as a result, and it'll kind of continue the logic of your SQL query into your results, and you'll understand whatever the person was trying to explore from a business standpoint. But I do want you to be aware of the fact that you can technically order by a column and not select it in your select statement if for some reason you want to do that. Okay, that's it for the order by lecture. Coming up next, we're going to quickly discuss a limit function, which allows us to actually limit the amount of rows that are returned in a query, and then we'll give you some challenges for the order by statement in conjunction with the limit statement. I'll see you at the next lecture. Welcome back, everyone, to this lecture discussion on the limit keyword. The limit command allows us to limit the number of rows returned for a query. It's useful for not wanting to return every single row in a table, but only view maybe the top few rows to get an idea of the table layout. Limit also becomes extremely useful in combination with the order by statement that we just learned about. Limit goes at the very bottom end of a query request and is the last command to be executed, because essentially what the limit does is after you're done filtering with the where statement, ordering with order by, and sorting, and any other sort of conditions or any filters you want to do on your query, the limit is just going to say, all right, how many rows do you want at the end of the day? So let's learn the basic syntax of limit through some examples. This should be pretty straightforward, and you should really be thinking about this in conjunction with order by in order to answer certain business questions. Let's jump over to pgadmin. Okay, here we are in pgadmin. Let's go ahead and explore this payment table again. First, what we could do is just select everything from the payment table. So I can say select everything from payment, and I get this variety of payment IDs, customer IDs, staff ID, rental ID, etc. And then I also get a payment date, which is a timestamp without a time zone, essentially just a day and then the hour, minute, and then second and milliseconds where this payment actually occurred. What we could do is order by this payment date in order to see either the oldest payments or the most recent payments. So what I can do is say select everything from payment and then say order by payment date. And if we run this on a timestamp, what's going to happen if we refresh this? Notice we get 2007-02-14. So this is in American formatting, meaning it's year, month, and then day. And if I want, I can either order this by default ascending to get 2007 to and then 14, or I could say descending, run this, and I see 2007 5/14, essentially 14th of May instead of 14th of February. So what this actually means is I can use order by in conjunction with limit to get the top n rows of something. So for example, I can answer the business question, what were the 10 most recent purchases in the payment table? So after I conduct my order by, I call in the limit keyword and then provide how many rows do I actually want. So if I just say 5, you'll notice here that right now it's returning everything if I scroll down here. If I say 5, run this, I keep scrolling down, but I only get 5 rows. So essentially what this answers is what were the 5 most recent rows or payments based off the payment date. So we can see the payment date here, and right now we're returning the 5 most recent payments. So this will allow you to get the top n of anything based off some column. So what we do here is just order by some column and then limit it to the top n results that we want. And it's up to you whether you want to do ascending or descending, depending on the actual data type that we're looking at. So we can see here, in fact, some of these payment amounts were zeros. So what I could end up doing is also filtering it where the amount isn't 0. So we can start to get really nice complex queries here. So I can say select everything from the payment table, saying select all the columns from this payment table. And then right here, we're limiting it to the top 5 most recent ones based off payment date in descending order. So starting from most recent, descending to the historical data. And I could also then say where amount is not equal to 0. So we run this, and now I can see the 5 most recent payments where there was actually a monetary transaction and it wasn't just a $0 amount. So this is where we start to see much more realistic SQL queries given just a few commands we know, we can already answer lots of business questions. We can, in this case, select everything from the most 5 recent payments where the amount wasn't 0. All right, so hopefully that gives you an idea of the power of limit. And sometimes if you want, you can simply do something like select everything from payment limit 1 to just quickly get an idea of what this table actually looks like. This would show you what data types there are, such as integers, small integers, timestamps, etc., and an example of what these actually look like. So some people like to quickly run this sort of command in order to just see the general layout of a table. Okay, so that's it for this lecture on limit. It's a pretty straightforward thing. Limit just comes at the end, and you can limit the number of rows returned. Very useful in conjunction with order by. So let's test your skills in the next lecture where we talk about some order by challenges. I'll see you there. Welcome back everyone to your set of challenge tasks regarding order by as well as the limit statement. So we'll start off by giving you the challenge task or business situation, then we'll go on to the expected result, the hints, and then the solution. So your first challenge task. We want to reward our first 10 paying customers. So the question is, what are the customer IDs of the first 10 customers who ever created a payment? Up next is the expected result. So the expected result are these 10 customer IDs. Here comes some hints. So the hints is to use the payment table, and you will need to use both order by and limit. And remember, you may need to specify ascending or descending on the actual payment date column. Here comes the solution. So the solution is to select the customer ID column from the payment table, and then you're going to order by payment date in ascending order. And if you want, you can just leave the ascending out of it because that is by default. And then the limit is 10. All right, let's move on to your second challenge. So the next challenge task is a customer wants to quickly rent a video to watch over their short lunch break. What are the titles of the 5 shortest, that is in length of runtime, movies? Okay, here comes the expected result. So the expected result are these 5 movies, and if you want, you can see the actual length of those movies is 46 minutes each. So you should get these 5 titles. Here comes some hints. So the hint is to use the film table and then take a look at the length column, and you can use order by and limit, and then remember you can use ascending or descending to get desired results. Here comes the solution. The solution is to select title and length, or just the title, since the question didn't really ask for the length of the films, from film, and then order by length, ascending, limit 5. Now I want to quickly jump to pgadmin to show you something regarding this query. So something I want to point out here is if we actually run this query of selecting title length from film order by length ascending limit 5, there's 2 things to notice here. One is that length is also highlighted, basically telling you later on we're going to discover that length itself is actually a SQL keyword, so we want to be careful on the way we use it. In this case, it'll work fine if we run this because it is a column name inside of this table. But something to keep in mind is you should try your best to avoid column names that match up with SQL keywords. And pgadmin alerts you to this with this highlighting. Now, one way to just make it clear whether or not you're using a column name or a keyword is the capitalization. So from the capitalization, it's quite clear that length here is a column name and not a SQL command. The other thing to note here is I actually don't know for sure if there's more movies that have a longer or the same runtime. So notice here are the 5 movies that PostgreSQL returned that are ordered by length in ascending order. So here are the 5 shortest movies, 46 minutes each, but there actually could be a 6, 7, 8, 9, etc. more movies that also have 46 minutes in length. So we don't actually know for sure if these are just the 5 shortest movies. We could have more. And what we could do is keep expanding on this limit, and then eventually we would see that the next limit in length has been reached, 47 minutes. So it's by coincidence that there's only 5 movies with the shortest runtime of 46 minutes. But just saying limit by 5 doesn't actually guarantee you that there's only 5 movies here with the shortest runtime. So keep in mind of that sort of issue that may arise when you're trying to solve a question like this. Okay, and finally, let's give you a quick bonus question. So here's a quick bonus question, no hints or anything for this one, just quickly. If that previous customer can watch any movie that is 50 minutes or less in runtime, how many options does she or he have? Keep in mind, you may actually not even need order by for this. So again, we're just asking how many movies can that customer watch that are 50 minutes or less in runtime. The expected result is 37 movies. And hopefully you can recall back to your select and where statement. So here's the solution. So all we need to do is select, and then we can count the title from film where length is less than or equal to 50. And keep in mind, I don't necessarily need to count the title column. I could be counting anything there. So that could have been an asterisk as well. All right. So coming up next, we're going to keep talking about different SQL commands, starting with the between command. I'll see you there. Welcome back, everyone, to this lecture on the between keyword operator. The between operator can be used to match a value against a range of values. So for example, we can ask, where is a value between a low and a high? And this is essentially going to be a condition you can tag along with a where statement. You should note that using the between operator is essentially the same as asking individually where a value is greater than or equal to low and a value is less than or equal to high. So note that the low and the high here are both inclusive. So it's actually including the endpoints there. You can also combine the between keyword with the not logical operator, essentially asking where is the value not between low and high. And this is the same as asking value less than low or value greater than high. Note here that we are exclusive of the actual low point and high point. So what I mean by that is for the not between statement, if you're saying something like value not between 8 and 9, if a value happens to be 8, it's not going to be included in the not between. Versus, if we take a look back at the between statement, that is inclusive, meaning if you wanted a value between 8 and 9, it would actually include 8s and 9s there. So keep that in mind. And if you want to change exclusivity versus inclusivity, you can just go back and use the AND operator and then specify less than or equal to manually yourself with the comparison operators. Now, the between operator can also be used with dates. You should note that you need to format dates, in this case, in the ISO 8601 standard format, which is essentially just 4 numbers for the year, a dash, then 2 numbers for the month, a dash, and then 2 numbers for the date, or the actual day. So that means it would look something like, where is the date between, and then as a string with single quotes in that particular format, year, 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 dash, month, month, dash, day, day, and then the other dates. Something to keep in mind is when using the between operator with dates, that also include timestamp information, so not just the actual day, but also the hour, minutes, and seconds. You should pay careful attention to using the between operator, especially since we have that issue of inclusivity versus exclusivity of the not between. So you should take into account the fact that a date time, that is both the date and the actual time information, would start at 0-100 hours. So that may have an effect depending on what the actual situation is and whether you want inclusivity or exclusivity around that midnight time or 0-100 hour time. Later on, we're going to study more specific methods to actually work with date time information types, so don't worry about it too much right now. It's just something to keep in mind for the future. Let's go ahead and get some quick practice with the between operator in pgadmin. Okay, here we are at pgadmin. What I'm first going to do is check out the payment table, since that's what we're going to be working with for our examples. We'll say select from payment table. We'll grab everything, but just limit it to just a few rows so we can see the general syntax here and general columns. We have the payment ID, customer ID, staff ID, rental ID, and then the amount and the payment date. So we're going to be working with these 2 columns here. Let's go ahead and see if we can use between on the amount column. Let's imagine we wanted to know the actual number of payments that were done between $8 and $9. So what we can do is say select from payments where amount between 8 and 9. If I just run this, it'll give me all the results, so we can see everything here is $8.99. And if I actually wanted to know the total number of transactions, I can just count the number of rows returned, and it's 439 rows. If I wanted to know the opposite, essentially everything that wasn't between $8 and $9, I can simply add not between 8 and 9. I can run this, and then I get the number of payments that were not between $8 and $9. Let's take a look again now at the payment date column. So what we can do is, let's imagine I wanted all the payments that happened on the first half of February of 2007. What I could do is, let's just select everything so we can get an idea of what's happening here. And we'll say where the payment date column is between, and what we're going to do here is make sure we format this correctly, which is going to be the year dash the month dash, let's say 01, and we'll say 2007 dash 02, and then the 15th. So we run this here, and we can see all these payments happen between the 1st of February 2007 and the 15th of February 2007. Now, something to keep in mind, especially when you're dealing with timestamp information, is that this timestamp information includes both the date and hour, minutes, etc. So that means PostgreSQL essentially has to decide, does a day start at 0-100 hours or at 2400 hours? And if you're dealing with exclusivity versus inclusivity, that actually might affect your logic. So what I mean by that is, take a look at the results here. They all actually happened on the 14th. So if you kind of scroll down, you'll see there's 27 rows, and essentially all the payments that happened between the 1st and the 15th all happened on the 14th. Now let's actually switch this to be all the payment dates from the 1st to the 14th. And this is where students often get confused. They would actually expect to see these results. But if I run this, you'll notice nothing gets returned. And that's because when we're dealing with this end date, it's actually only going up to the 0-100 hour mark. It's not going to the end, which would be the 2400 hour mark of the 14th. Which is why for these sort of between statements, when you're dealing with timestamp information, you just have to be careful of that. So you always want to double check and make sure you're getting the results that you expected. So in this case, I'd have to go all the way to the 15th to actually include information that happened on the day of the 14th. Okay, and later on, we're going to learn a lot more about how to deal with timestamp information such as this. So that's it for the between examples. Coming up next, we're going to learn about a couple more SQL keywords that are very helpful in different types of queries. I'll see you there. Welcome back, everyone, to this lecture on the in operator. In certain cases, you want to check for multiple possible value options. For example, if a user's name shows up in a list of known names. So instead of having to write a bunch of or statements, such as name is equal to David, or name is equal to Claire, or name is equal to Zach, we could use the in operator to just create a condition that quickly checks to see if a value is included in a list of multiple options. So you can check something like, where name in Zach, David, and Claire. So the general syntax would be something like this, value in, and then a bunch of options. So for example, an example query could be select the color column from table where color in red, blue. So note here that the options are in this little list in parentheses, and then we use the in operator to basically specify that we're checking for the color condition that happens to be either red or blue. So these are a bunch of or statements. So anything red and anything blue will be returned to us. And we can always expand this to more options quickly. So we can say now where the color is red or blue or green. So essentially there's a little or statement in between all these. Keep in mind you can also combine this with the not operator to essentially do this excluding these values. So where color is not in red or blue. It's essentially every color that is not red or blue. Let's go ahead and quickly see some examples in pgadmin. Here we are at the query editor. I'm going to take a look at the payment column, or a payment table. We'll just select everything from payments. Let's just limit this to 2 rows so we can take a look at the result here. And notice we have an amount column. Let's first figure out what are the actual distinct values that are available to me in the amount column. So what are the unique amounts that we're charging? So we can say distinct amount from payment, and I'm not going to limit this since I want everything back. I run this and I can see I have $10.99, $1.99, etc. And what I could also do, just for clarity, is order this by amount, as we've seen before, and now I can order amount 0, 99, etc. So maybe I want to figure out all the orders that happen to be 99 cents, 198, and 199. So how could I do that? Well, what I could do is I could select any columns I want, or everything from payments, and then we'll say where the amount is in, and here we'll go ahead and specify 99 cents, 198, 199. Note here that I'm not using strings or quotes because this is a numeric data type. So if we go ahead and run this, we get back a bunch of values where the amounts happen to be in 199.99 cents or later on 198. And if I wanted to figure out how many payments actually occurred that happened to be one of these three values, I could run this and I get back that there were 3,301 payments. Now let's imagine I wanted the actual opposite information. I wanted to count out how many payments were not 99 cents, $1.98, or $1.99. Well, there's a couple things I have to do here. First, notice here again I have the parentheses of that list of options. If I just add not in front of this and run this, then I get back the amount that is not in 99 cents, 198, and 199. So there's 11,295 payments that are not these three values. And let's go ahead and explore this on a string column to finish this off. We'll just say select everything from customer. Take a quick look at this. I have the first name and last name. So let's go ahead and select all the columns from customer where the first name is in, and let's just give some options like John, Jake, and Julie. We'll go ahead and run this, and here I can see there was no one named Jake in this particular table, but we did have a Julie and we did have a John. Okay, so that's the way the in operator works. Main things to keep in mind is that you're using parentheses here and then commas to separate out your options, and your options should be matching the general syntax of the column. So we want to make sure that for numerics, we're providing numerics in the list, and for strings, we're providing these single quote strings here. And we can always say not in if we wanted to see essentially the exact opposite. All right, that's it for this lecture. I'll see you at the next one. Welcome back, everyone, to this lecture on like and I like. And really, it's more than just these two keywords. This lecture is about using pattern matching with string data. We've already been able to perform direct comparisons against strings, such as where first name is equal to John. But what happens if we want to match against a general pattern in a string? That enables us to answer questions such as all emails ending in @gmail.com, or all names that begin with a capital A. The like operator allows us to perform pattern matching against string data with the use of special wildcard characters. So there's two main wildcard characters we're going to cover right now, and that is the %, which matches any sequence of characters, so essentially any number of characters, and then there's the underscore, which matches any single character, essentially a wildcard for just a single character inside of a string. So let's see a couple of examples of this. We'll start off with the %. So the % is a wildcard character for any sequence of letters or characters. So this basically specifies something like all names that begin with a capital A. So we would say where name like and then a string where we have the capital A and then the %, essentially saying you'll match with anything that starts with a capital A and then has any number of sequence of characters after it. Then we could do something like all names that end with a lowercase a. So then we have where name, like, and then we start off with the % and end with a lowercase a, essentially saying that anything or any sequence of characters can come before that lowercase a. Notice I've been saying things like uppercase or lowercase, and that's because like is case sensitive. However, you can always use I like, which is going to be case insensitive. Now using the underscore allows us to replace just a single character. For example, let's imagine we were storing the Mission Impossible films and they were titled something like Mission Space Impossible Space and then 1, 2, 3, or 4, etc. So we could do something like where title like and then Mission Impossible space, and then the underscore just leaves a single wildcard place to fill in whatever number we're looking for. Now you can use multiple underscores. So imagine we had a version string codes in the format, something like version numerical or hashtag A4, and then version hashtag B7, etc. So that would be something like where value like version hashtag and then 2 underscores, where those 2 underscores can be filled with any sort of characters you want. So this essentially leaves open any 2 characters to fill in those specific underscore positions. Now what's nice about this is then we can begin to combine pattern matching operators to create more complex patterns. So take a look at this example where we say where name like and then underscore HER %. So if we think about what this is actually asking for, this is returning back, and we've color coded it here, a single wildcard space for the first letter. And then after HER, any sequence or any number of characters can occur. So here we have Cheryl, which starts with a single C, then HER, and then has 2 characters after that. Or Teresa, which has a capital T, HER, and then ESA. So notice here, it has to be just 1 character before HER, but then any number of characters after it. So this allows for really powerful pattern matching code. Now we're just focusing on like and I like and those 2 wildcards of an underscore and a %. But in case you're familiar with something called regular expression or regex in other languages such as Python or C++, I want you to keep in mind that PostgreSQL actually does support these full regular expression capabilities, and you can check out the link here or just go to the docs and look up functions matching. And not only does it have information on like and I like, but it also goes into much more detail on regular expressions. We're not going to cover those for right now. Instead, we'll just focus on like and I like. Let's check out some examples in pgadmin on our own DVD rental database. Okay, here we are at the query editor. Let's imagine I wanted to figure out how many people actually have a name that starts with J. Well, I could say select, and we'll start off by selecting everything from the customer table, and we're going to check where their first name is like, and then notice here I'm going to say capital J and then %. And then if I run this, I get back the results for everyone that has a first name that starts with the letter J. And if I wanted to actually figure out how many of these there were, I could simply just provide a count on the number of rows returned, and I get back there's 65 people who have the first name that starts with the letter J. Now I can keep adding on to this, so then I could say something like and last name like, and let's go ahead and do something such as starts with an S. And I'm not actually sure if there's someone like this, but we can run this and check. Okay, looks like there's 5 people. Let's go ahead and explore those names. So just grab all those rows for those customers, run them, and here we can see there's Julie Sanchez, Jeffrey Spear, etc. Okay, so that's how it worked for the %. And notice here that I had to make sure to use capital J because I'm using like. If I were to lowercase one of these and run this again, I get back nothing because this is case sensitive. Alternatively, if I don't want to worry about case, I can use I like, run this, and it'll return back the results. Whoops, accidentally changed this to J. Let's go ahead and change that back to S. Run that again. Okay, so there we go. I like is case insensitive, which means it doesn't matter if I use the lowercase j here or a capital J and a capital S. I run this again, it's going to be the same result either way. So I like is case insensitive, like is case sensitive, just something to keep in mind. And we can always add in more than just a single wildcard character. For example, we could do something like this. I can say first name, like, and let's imagine I wanted to figure out people who have the sequence of characters ER somewhere in their name. So I could do something like %, ER, %. I run that. And basically what that's asking for is anyone who has ER somewhere in their first name. Now notice it'll return something back like Jennifer. So ER is at the end of Jennifer, and this sequence of characters can also be nothing. It can be 0. So that means ER just has to show up anywhere inside this name. So Kimberly has the ER here in the middle, Catherine does as well, but something like Heather has it at the end, and that still is okay with this sort of code. So just because it has a percent sign doesn't mean it has to fill in something there. It can be blank. And we can keep doing this. Maybe we want something like her somewhere in the name. Run that, and I can see Catherine, Heather, etc. Or we can do what we did in the slides, which is replace one of these with a single underscore, which means only one character is now allowed in that space. So now when I run this, I only see back Cheryl, Teresa, Sherry, and Sherry with an I. So note the difference here is now only one character is allowed before this HER. Something that's also important to note, and we'll finish this off, is to show you that you can also add in the not operator to essentially get the opposite. So I can say, give me everything that's not like this, essentially everyone that isn't these 4 people. So I can just run this, and here I see everyone that wasn't in that list of 4 people. We then can combine this with things like logical operators such as AND. So I could do something like, let's say we're first name, like, and let's say it has to start with an A. So we go ahead and run this, and we can see everyone whose first name starts with an A, and let's go ahead and order it by the last name. So we can start kind of getting more complicated here. Order by last name, run this, and now I can see Alma Austin, Angel Barkley, Agnes Bishop, etc. But let's imagine for some reason I didn't want anyone whose last name started with a B. So I wanted to remove Barkley, Bishop, Bradley, Burns, and Butterfield here. Well, I can begin adding things. So where first name is like A, and then we can say something like and last name not like, and then we'll say starts with a B. So we go ahead and run this, and now I can see I got rid of those people that had a last name that started with a B, and yet retained everyone who has a first name that starts with an A. So you can begin to create really custom patterns for whatever you're looking for with just these wildcards. So keep in mind you always have the percent sign and the underscore available to you. Percent sign for a long sequence of characters, underscore just for a single replacement character. All right, thanks, and we'll see you at the next lecture. Hello everyone, and welcome to your first general challenge lecture. So I'm really excited for you to take on this first general challenge because these general challenge tasks are going to utilize all the skills that you've learned so far. You'll receive the general challenge task, and then you'll get hints to the challenge and then the solution to the challenge. These challenges are going to be a little more difficult than what you've seen earlier, so try breaking down the problem into individual tasks in order to solve the task completely. So let's go ahead and get started. Your first challenge and business task that I want you to answer is this. How many payment transactions were greater than $5? Again, just what's the number, the count, of how many payment transactions were greater than $5? Okay, coming up next are the hints, so go ahead and pause the video now if you don't want to see the hints yet. Moving on to the hints. So you'll need to use the payment table, and you'll also need to use count and where along with some sort of comparison operator in order to distinguish what's greater than $5, so just keep that in mind. Okay, coming up next is the solution. So the solution is actually pretty straightforward. You want to select count amount from the payment table where the amount is greater than 5. So that's taking a couple of concepts, just the general concept of selecting from, that very first thing we learned, then the concept of counting the amount column, and then using where along with some sort of comparison operator to filter out which amounts we were looking for. So again, that was select the count amount column from payment table where amount is greater than 5. Remember to put that semicolon in to end your query. Okay, next business task. How many actors have a first name that starts with the letter P? Again, how many actors have a first name that starts with the letter P? Okay, coming up next is a hint. So go ahead and pause the video now if you don't want to see that hint yet. Okay, here comes the hint. So you will need to use the actor table in order to answer this question, and you'll also need to use the like statement and some sort of wildcard operator, such as the percent sign or the underscore. So go ahead and review the like lecture if you need any refresher on how to use that percent sign or underscore wildcard operators. Okay, coming up next is the solution to this challenge. So here it comes. So the solution is select count, and in this case I'm just selecting all the rows, so you can see it in asterisks here, and that's because I just want to count basically all the rows from actor where the first name column is like, and this is where it gets a little tricky, but you have to say like, single quote, capital P, percent sign, quote. And that's because what's going to happen here is you're going to say select the count asterisk, meaning just count all the rows from actor where your first underscore name column is like P percent sign, meaning where the value of first name column starts with a P. Okay, so go ahead and review that solution. Make sure you type it out yourself in case you weren't able to get it. But coming up next is one other challenge task. So here it comes. Okay, your next challenge is how many unique districts are our customers from? That's how many unique districts are our customers from? Okay, coming up next are some hints on how to solve this challenge. So here comes the hint slide. So you'll need to use the address table, and you'll also need to use count and distinct. So go ahead and review the distinct lecture in case you don't remember how to use distinct. But you'll need that in order to solve the challenge, which was how many unique districts are our customers from? Okay, so coming up next is the solution. So go ahead and pause the video now if you don't want to see the solution yet. Okay, here comes a solution for it. So the solution was to select count distinct district from address. So this is going to basically do this. It's going to say select, and if we start from the inside here, it's going to grab all the distinct districts. So that means if you have, for instance, a district called Alberta, if you have it several times throughout that column, so several rows have the value of Alberta in that district column, what distinct is going to do is just select all the unique ones. So it means it'll just filter it down so Alberta only shows up once, or that particular district only shows up once. And then what count is going to do is just count all those distinct districts. And that's basically going to give you the answer of how many districts or unique districts are the customers from. And you have to get that from the address table. Okay, so one more challenge. I want you to retrieve the list of names for those distinct districts from the previous question. So this is going to be a really similar question, but I just want you to make sure you really flesh out your understanding fully and just retrieve the list of names for those distinct districts from the previous question. Okay, here comes the hints. So again, you need to use the address table, and really strong hint, this is going to be very similar to the previous challenge solution. So you should really only be editing basically one word. Okay, so hopefully you can get it, but if you don't, go ahead and pause the video now, try to get it. And now we're going to do the solution. So here comes the solution for it. The solution is to basically just remove that count. So if you just say select distinct district from address, you won't get the actual number count, you'll just get that list of the distinct districts that the customers are from. Okay, hopefully you're able to get that. Another challenge here is how many films have a rating of R and a replacement cost between $5 and $15. That's how many films have a rating of R and a replacement cost between $5 and $15. Okay, go ahead and pause the video now. Try to solve this challenge on your own using your SQL querying skills. And up next are some hints on how to solve this challenge. Okay, here comes the hints. So the hint is you'll need to use the film table, and you may also need to use between and a where statement with some sort of comparison operator in order to solve that issue of between that $5 and $15. Hopefully the word between earlier was a clue for you for you to figure that out on your own. Okay, so those are your hints. Go ahead and pause the video now if you want to attempt the problem on your own. But coming up next is the solution. Okay, here comes the solution. So the solution was to select count asterisk, so just select the count of all the rows from film, where the rating is equal to that string R, so single quote R, single quote, and replacement underscore cost column is between 5 and 15. Notice I don't have to put strings between 5 and 15 because they're both just numeric data types. Okay, so let's go ahead and break this down just a little further. Sometimes it confuses people why you have to just select count asterisks here instead of like title or something. And that's because by saying count asterisks, you're basically just saying count the number of rows returned, which makes sense because it doesn't matter what column you select, you're still going to be counting the same number of rows there. So you're saying just select the count of the number of rows from film that get returned when you select the rating is equal to R and the replacement cost has to be between $5 and $15. Okay, so another challenge. This one's going to be maybe a little trickier, testing your pattern matching skills. How many films have the word Truman somewhere in the title? So that's how many films have the word Truman somewhere in the title. Okay, so coming up next are some hints. Go ahead and pause the video now if you don't want to see those hints yet. Here comes the hints. So you'll need to use the film table in order to solve this, and you'll also need to use like with some sort of wildcard operator. So again, you can review the like lecture in order to get an understanding of how to use those wildcard operators in case you've forgotten. All right, coming up next is the solution. Here it comes. So the solution is to select count asterisk. Again, we just want to select the count of the number of rows returned from film, where the title column is like, and this is where maybe it was a little tricky for you, but remember the question asked, if we just go back 2 slides here, it asked how many films have the word Truman somewhere in the title. So not at the beginning, not at the end, just anywhere in the title. And that means we had to use wildcard operators on both ends of Truman, meaning any number of characters or any sequence of characters can come before Truman, and that includes spaces, and any sequence of characters can come after Truman. Okay, so that was the solution. So select count asterisk from film, where the title is like, and then single quote, %, Truman, %, single quote, semicolon to end that query. All right, great job. Hopefully you found those challenges straightforward, a little tricky, but not too hard. They should have been pretty basic. What we're going to learn from now on is going to really up your skill level in SQL. Learn how to do joins and group bys, which are some really powerful SQL statements, and that will really take you to a much more professional level understanding of SQL and the ability to use PostgreSQL database in order to do some real professional queries. Okay, thanks everyone. Hope you enjoyed those challenges, and I will see you at the next lecture. Thanks.